Today we are going to study this chapter 6, ratio and proportion, and we are going to discuss the three first sections, which are introduction to ratios and rates, introduction to proportion, and unit conversion, and we will focus in American system. The ratio is the quotient of two numerical quantities or two quantities with the same physical unit. Then the ratio can be the ratio of 3 to 4. Yes, we can express the ratio of 3 to 4 just between two numbers. And in this case we can write 3 over 4. We can write as a fraction. 3 to 4 we can write using words, or 3 and these two dots 4 means also the ratio of 3 to 4. Also can be the quotient of two numbers of two quantities with the same physical units. For example, if we had 3 hours over 4 hours, yes, 3 hours to 4 hours. 3 hours, 4 hours, and if we had the same physical units for the quantities. And there is these three different ways we can express the ratio of two numbers. That's the ratio of 3 to 4 in this particular case. And in this case, we want to express these ratios as a fraction, and if possible we want to reduce the answer to the lowest terms. And in the first case we had 36 to 24, and 36 we can express as fraction, and we can simplify the fraction. And we can, for example, divide by 6 first. And we had 36 divided by 6 is 6. 24 divided by 6 is 4. Then we can divide by 2. And will be 3. 36 divided by 2 is 3. Or 2. Then 36 over 24 is equals to 3 over 2. Also, we can divide by 12, and 36 divide. Also, we can divide by 12. Yeah? Directly, we can divide by the greatest common divisor. And 36 divided by 12 is 3. 24 divided by 12 is 2. And we will get the same answer. And either way is right, is correct. Then finally we can say that 36 over 24 equals to 3 half. That's 3 over 2. And let's try the next problem. We had 0.12 divided by 0.18. And we know when we divide, if we need to divide decimals, we don't want decimals in the denominator. Then what we can do is we can move 2 places. In the denominator or the divisor is the same. Yes? We move 2 places, and we had to do the same in the numerator or the dividend. Yes? We need to move 2 places also here. And if we move 2 places in the denominator, we need to move 2 places in the numerator. If we do that, it's 12 over 18. It's the same as if we multiply by 100 on top and bottom. Yes, it's the same thing. Now what we had to do is just to reduce to the lowest terms. Then we can divide by 6. Divide by 6. And 12 divided by 6 is 2. and 18 divided by 6 is 3. 2/3. Then finally we had 0.12, 18 equals to 2/3. For the next one, then for the first thing we want to express this one as a fraction. Then we had 0.14, 0.44. Now we don't want fractions in the denominator, and we need to move to the end, the decimal point. 1, 2. Then we had here 44. 1, 2. We had 14. Now we reduce to the lowest term. We can divide by 2. That's why here we need to divide by 2. We need to divide by 2. 14 divided by 2 is 7. 44 divided by 2 is 22. And finally we had 0.14 equals to 7/22. Then we want now to express this ratio as a fraction in the lowest term, 22 minutes to 12 minutes. And in this case, we had the same units. Yes, we had 22 minutes over 12 minutes. Because we had the same unit, it's like in the same case, we had the same number. As we can cancel out, and finally we had 22 over 12. Then now we can divide by 2 to reduce to the lowest terms. We can divide by 2. 22 divided by 2 is 11. 12 divided by 2 is 6. And finally we had 22. 12 equals to over 6. Now, new concept. What is a rate? The rate is a quotient of two measurements with different units. And in the last problem, we had the ratio between two quantities with units, but the units were the same. Yes, but in this case, we had a problem in which we had the quotient of two numbers with different units. And in this, let's try to solve this problem. Lenny travels 180 kilometers on 14 liters of gasoline. Express the ratio distance traveled to gas consumption as a fraction reduced to the lowest term. And here we had two different quantities because we had two different units because we had two different quantities. One, we had distance, which is 180 kilometers, and we had the amount of gas, or gasoline, which is 14 liters. And let's write this one here, as we need to. And we had the distance kilometers. And we can express this one like D equals to 180 kilometers. And the other thing, we had the gas, which is 14 liters. And we can express this one like 14 liters, like that. Then we want the ratio of the distance to gas consumption. As this is, we want to express distance to gas. And the ratio we want to find is distance to gas. And let's write this distance to gas. Then what we had on distance means we want to write this one as a fraction, distance to gas. Distance is 180. And 180 to gas, but the gas is 14 liters. Here we can see we had two quantities with two different units. One is kilometers, the other one is liters. Now we already had the fraction. Now we want to reduce to the lowest term. Then we can divide by 2. 180 divided by 2 will be 90. 14 divided by 2 will be 7 liters. And in this case, we had 90 kilometers to 7 liters. And what this is, what that does mean is the car travels 90 kilometers on 7 liters of gas. Let's write that, and let's write here 90 kilometers for 7 liters. And this means the car travels 90 kilometers on 7 liters of gas. Unit rate. Then we know proportion, rate. Now unit rate. What is the definition of the unit rate? It's a rate whose denominator is 1. Yes, it's a rate whose denominator is 1. We can see here the denominator in this case was not 1, it was 7. Then in unit rate, the denominator must be 1. Then let's try to solve this problem. Jacob drive 120 kilometers, which is a distance, in 3 hours. Find his average rate of speed. And in this case, the rate or the speed is distance over time. Then we want to find the ratio distance to time. And the distance we had in this case, the distance is 120 kilometers and the time 3 hours. And the ratio distance to time will be distance over time. Yes, distance over time, and the ratio we want is 120 kilometers over 3 hours. And 120 divided by 3 equals to 40 kilometers per hours. Then in this case, we can see the denominator equals 1. Then this means the speed, yes, the speed equals to 40 kilometers per hour. Yes, the speed is 40. The average speed is 40 kilometers per hour. Let's try the next one. Then Francie worked 5.5 hours, received $120 for her effort. What is her hourly salary rate? Round your answer to the nearest 100. And in this case, then we want to know how much money she received per hour. Yes. Then we need to the ratio is money to hour, or salary per hour, salary to hours. And what we know is, and let's write here, salary to hours. This is the ratio we need to find. And the salary she received is 120 and $120. This is the unit we have on top. And she received $120, 5.4 hours. Then now what we can do is we cannot divide by 5. We can write this one like 120. We move the decimal one place, 5.4. Then we have here dollars to hours. And we can reduce this fraction as we can divide by 5. If we divide by 5, then we have $240 divided by 11 hours. And just to practice, let's try to divide this one. Divide this. See, we have enough space here. Just to practice. Yes, just to practice. Then, how many 11s are in 24? We had 2. 2 times 11 is 22. And 24 minus 22 is 2. Bring the down. Then how many 11s are in 20? Maybe just 1. 1 times 11 is 11. And we had here 9. 20 minus 11 is 9. Now we need to, we have decimal point here. We need to place the decimal point in the divisor. We add the 0, bring the 0 down. And how many 11s in 90? We had 8. 8 times 11 is 88. 2. Let's try to one more. Then how many 11s in 20? Just 1. And 1 will be 9. Bring this 0 down. How many 11s in 98? 8 times 11 is, let me write here, okay, I don't have the space there. 8 times 11 is minus 88, 2, and you can continue dividing. Then now we can write this one. 20/40 over 11 is 21.818 dollars per hour. But we need to answer to the nearest 100. Then to the nearest 100 is this position. Then we need this decimal place. Then we will 21.8. The next number is greater than 5. Then we need to add 1 here. And it's dollars per hour. Then she received $21.82 per hour. Yes, she received $21.82 per hour. Then this is the answer, and this is the answer. And in this case, when we need to express as unit rate, we don't want any number in the denominator. And we had 40 kilometers per hour, and in this case also we don't want the denominator. We want just the number. That's $21.82 per hour. Dollars per hour. And I did that division just to practice the division of the decimal numbers. Then once car, in this case, we had one car travel at 271.8 miles on 10.1 gallons of gasoline. And this is the car one. The second car travels 257.9 miles on 9.1 gallons of gasoline. Which car gets the better gas mileage? Then to answer, we need to express that information as a unit rate. Yes, as a unit rate. Then we need to divide, yes, we need to express the miles to gallons. Yes, this is the ratio we want to, and we want to express the miles or the distance, yes, miles to gallons, or distance to gallons. Yes, how much distance to gallons. And let's write for the car one. For the car one, then miles to how many gallons. Then for the cars one, we had 271.8 miles to 10.1 gallons. Yes, we can write gallons. The miles, let's write here miles. We can write like that, and gallons we can express like that. And let's write here. Probably better to write yes. This is for the car one. Then let's try the same thing for the car two. Then we had 257.9 miles to gallons will be 9.1 gallons. Yes, in this case we will use the calculator to find the division, to find the rate unit. Yes, because we don't want any denominator. Then if we divide 271.8 divided by 10.1, and we will have 26.91 per gallon. This is for the car one. For the car number two, we will have, we divide 257.9 divided by 9.1, we will have 28.34 miles per gallon. Then now we need to answer which car gets the better mileage. And in this case, this car will be travels 26.91 mile on 1 gallon. But the second one, we will travel 28.34 miles on 1 gallon. Yes. Then what of these two will be better? Yes. Then the second one, the second car gets the better mileage. Yes. Yes. Because travel more distance with the same gasoline. Yes, travel more distance with the same gasoline. Then in the second car travels 28.34 miles per gallon. Yes, and we can write here the second car gets the Now we will move to the section 6.2, which is the introduction to proportion. Then what is a proportion? A proportion is a statement that equates to ratios or rates. Yes. Then we had one ratio here, and we had the equal sign in between them. Then why is important the proportion? Because if we multiply the streams, which are these two numbers, and we multiply the means, which are these other two numbers, the product of these two quantities, streams and means, are equal. Yes. Then for any proportion, the product of streams, A times C, equals to the product of means, B times C. Then A times D, yes, equals to B times C. And this property we can use to solve problems. And let's try to solve this set of problems. Then we want to know which of the following proportions are true proportions. Yes. Then let's see. To do that, we will use the property we know. The product of the streams must be equal to the product of the means. Then the product of the streams must be equal to the product of the streams. And what we have here is 4 times 7 must be equal to 9.9 times 3. Here is multiplication. Then 4 times 7 is 28. But 9 times 3, let me write in the right order, just to be, it's the same, but just to be organized. And we will have 3 times 9. 3 times 9 equals to 27. Then the product of the streams are not equal to the product of the means. Then these are not equal. Then this is a true proportion. The answer is no. It's not a true proportion. Yes. Here we need to write no. It's not a proportion. Let's try the next problem. And the product of the streams must be equal to the product of the means. And 9 times 21 must be equal to 7 times 27. If we multiply 9 times 21 will be 9. 9 times 1 will be 9. 9 times 2 is 18. Is 189. And 7 times 7 is 49. Carry the 4. 7 times 2 is 14. Plus 2 is 18. Then we had the product of the streams equals to the product of the means. Yes. Then it's 189 equals to 189. And this is a true proportion. The answer is yes. It's a true proportion. Then let's try the other two problems. Then in this case, we want to see if these proportions, if these are really is a true proportion. Then the product of the streams must be equal to the product of the means. Then 7 times 5 must be equal to 2 times 9. 7 times 5 is 35. 2 times 9 is 18. They are not equal, then and we don't have, this is not a proportion. Yes. And the other one, we will do the same thing. The product of the means must be equal to the product of the product of the strings must be equal to the product of the means. Then 4 times 6 equal to 8 times 2. 4 times 6 is 24. 8 times 2 is 16. Then the product of the strings are not equal. The product of the string is not equal to the product of the means. Then it is not a proportion. Yes. The next thing we want, we know the product of the strings must be equal to the product of the means. And this property is called the cross product or the cross multiplication. And we can use this property to solve proportions in which one of the terms of the proportion, we can solve problem in which one of the terms of the proportion is unknown. Yes. For example, in this case, we had a proportion, but we don't know one of the terms. Then we can use the cross product or the cross multiplication to solve the problem. Then first, we apply the cross product, and the second thing we want is to solve the resulting equation. Yes. And the step number one, if we want to solve proportions, the step number one is we will apply the cross multiplication and then we solve the equation. Then let's apply the cross product. Then 3 times 12 equals to 4 times x, or just for x. 3 times 12 is 36 equals to 4x. To solve for x, we divide by 4 on both sides of the equation. We can cancel out. 36 divided by 4 is 9. Or x equal to 9 is the same. Then x must be equal to 9. Yes. In this case, we had 5 over x equal to 4 over 6. And we had a proportion, then we can use the cross product to solve the problem. Then 5 times 6 equals, we apply the cross multiplication, x times 4, or is the same like 4x. It's the same thing. 5 times 6 is 30. For x divided by 4 divided by 4 is cancel out. And now if it's possible, we can reduce. We can divide by 2, will be 15. And the x equals to 15 over 2. In this case, we want to solve this proportion 3 equal to x over 6. And we want to apply the cross product or cross multiplication to solve. And because we need a fraction, then we can rewrite this one like 3 over 1 x over 6. And now we can apply the cross product. And we can write 3 as 3 over 1. Then 3 times 6, let me write 3 times 6 must be equal to 1 times x. 3 times 6 is 18, and we know 1 times x, we can just write like x. And x equals to 18. In the other example, we had one of the terms of the proportion is an expression. And yes, we need to be careful when we multiply this expression. Yes, when we multiply 2 times x plus 1 times 3, we need is everything we had on top, yes, 2x plus 1 is multiplying by 3. And yes, we need to be careful with that. But we will solve in the same way we solve the other proportion. Yes, we multiply the strings, must be equal to the product of the means. Yes, we use the cross product. And in this case, we had 2x plus 1 times 3 should be equal to 15 times 1. And in this case, I suggest if you had an expression in any of the terms of the proportion, just use parentheses. Yes, that indicate all this expression is multiplying by 3. Then to solve this one, we need to distribute. Then we distribute through the parentheses. And 2x times 3 is equals 6x. 3 times 1 is 3. 15 times 1 equal to 15. Now we need to solve the equation. Then it's two steps equation. The first thing we had to subtract 3 on both sides. And we had 6x, let's cancel out, equal to 15 minus 3 equals 12. Then the next step, the second step, is divide by 6. By 6. And we had 12 divided by 6 equal to 2. And x equal to 2. In the next problems, we had word problems. As we had word problems, and we want to express we want to express this one as a proportion, and we want to solve that proportion. And in the first problem, we had if 7 apples cost $3.15, how much will be 10 apples cost? And we are assuming an equal rate. As we assuming is we can write as a proportion. When we had a word problem, the important thing is if we had on top, in this case, apples, then in both proportions, our apples must be on top. And if we had the cost, yes, in the denominator, or the dollars, yes, in the denominator, then in both proportions, that quantity must be in the denominator. Let's write that. Then we had 7 apples. Yes, 7 apples cost $3.15. Then we had apples on top. Then how much will 10 apples? Then we need to write apples on top. How much will 10 apples cost? Then the important thing here is we have apples and we had the cost of the dollars, yes, the dollars in the denominator. You can write in the other way also, dollars over apples. But the important thing is in both proportions, the same quantity must be the same quantity. If we had apples on top, the same quantity must be on top. And if we had x on dollars, the same quantity must be in the denominator. This is the important thing when we write a proportion. Once we had the proportion, yes, we need to solve in the way we learn. Yes, we can use the cross multiplication. Then we had here in this case 7 times x, oh just 7x equals to 3.15 times 10. And 7x equals 3.15 times 10. We know we need to move one place, then will be 31.5. to solve for x, to get x by itself, we need to divide by 7. And x equals 31.5 divided by 7 is 4.5. Then means 10 apples cost $4.5. 7 apples cost 3.15, but 10 apples cost $4.5. Then let's write here 10 apples cost $4.5. Let's try the next problem. In this case, we had Eloise and Susan, and they are planning a trip to some national park. On their trip, 3 inches represent 50 miles. 3 inches represent 50 miles. Then how long is their trip? Is the route measured 4.5 inches on the map? Then we had two quantities. We had inches and we had miles. Yes. Then now we need to write the same unit up top and the same unit of bottom for both proportions. And let's write inches to miles. Yes. Then we had 3 inches represent 50 miles. Then we had inches on top, then here we had inches, then 4.5 inches, how many miles represent? And here we had we had inches on top, we had inches, and we have miles in both cases. And always we need to check that. We had inches, miles. Now we need to solve the proportion. And we apply the cross product, and then we will have 3x, 3 times x is 3x, equals to 50 times 4.5. Then let's solve what we had on the right side of the equation. 3x equals. Then we can solve this one. This mixed fraction we can express as fraction. 4 times 2 is 8 plus 1 is 9. 9 half. Yes. Then we can also multiply this one. 50 times 9 will be 450 divided by 2. But we can also divide 450 divided by 2 is 225. Now we can divide by 3 to solve for x. Then 225 divided by 3 equals to 75. And x equal to 75. And now we can answer the question, how long is their trip if the route measures 4.5 inches on the map? Then the trip will be 75 miles. Yes, because 4.5 inches represents 75 miles. And let's write this one. Then here we have 75. And then we can write that 4 inches represent, let's write on the map, represent 75. Now we will move to the section 6.3, which is conversion of units or unit conversion. And we will start first with the American system. And let's start with the units of length. And in the unit of length, we had these conversion factors. We had 1 foot equals to 12 inches, 1 yard equal to 3 feet, 1 mile equals to 5,280 feet. And we will use these conversion factors. We will use these conversion factors of these unit rates to convert from one unit to another unit. Then I want to show first is why we can use this rate units of these rate units to convert from one unit to another unit. And we have this 1 foot equals to 12 inch. And what happens if we divide by 1 foot on one foot on both sides and 1 foot. Let me write better this one. I can write better. Let's see. 1 foot. And 1 foot divided by 1 foot, this equals to 1. And we have 1 equals to 12 inches over 1 foot. And we can see when we multiply by these conversion factors, what we are doing is we are multiplying by 1. And when we multiply by 1, we don't change the number. Like 5 times 1 equals to 5. And this is why we need to convert one unit to another. We can multiply by the conversion factor because the conversion factor equals to 1. We are not changing the number when we multiply by the conversion factor. And we can also, here, we can divide by, instead of divide by 1 foot, we can divide by 12 inches. Then in this case, this will be equals to 1. Then 1 foot equals to 12 inches. Then we can write the conversion factor in the way we need. Yes, we can write 12 inches over 1 foot, or we can write 1 foot over 12 inches. It depends on what conversion factor we will select, we will use, will be depend on what unit we need to convert. And let's see how we will apply these conversion factors when we need to change from one unit to another. Then we want to change 24 inches to feet. Yes, this is what we want to do. And we want to change 24 inches to feet. Then we will write the 24. This is we start. This is we want to convert. And we will write the conversion factor. We will select the conversion factor that cancel out the unit we don't want. In this way, we don't want inches. We want in feet. Then we need to write in the way the inches cancel out. Then we want to write these conversion factors. We will select what conversion we need to use in the way we had inches in the denominator and feet on top, because it's the only way we can cancel out the inches. Then in this case we had 12 inches. Yes, we had 1 foot equals to 12 inches. Then 1 foot equals to 12 inches. And this is the right conversion factor because the inches cancel out, and we had finally the unit we want, which is feet. Now 24, well, times 1 is 24. We had feet divide by 12 because the inches cancel out. And 24 divided by 12 equals to 2 feet. Then finally, we can say is 24 inches equals to 2 feet. And this is the answer. Now let's solve the next one. Change for 8 feet to inches. And we start with 8 feet. Now we want in inches. Then we need to select the conversion factor in the way the feet cancel out. And we need feet in the denominator. Yes, and we need inches on top. And in this case, we need to use this conversion factor. Yes, we need feet in the denominator, 1 feet and 12 inches. And this is the right conversion factor because feet must be cancelled out. And the final answer is in inches, which is the unit we want. And now we multiply 8 times 12. And we have here is 8 times 12 inches. Divide by 1. We don't need to divide by 1 because we will get the same number. Then 8 times 12 will be 96 inches. Then now we can say 8 feet equal to 96 inches. This is the answer. Then let's try another problem. Then in this, we want to change feet into jar, 36 feet to jar. Yes, we want to change 36 feet to jar. Then we know the conversion factor we need to use is 1 jar equals to 3 feet. Then in what way we need to write is depend on the problem. Yes, and this is, I want just to do one more time, just to show why we can divide by the conversion factor. What we can multiply by the conversion factor. This is 1 feet, 1 jar. Then here in this case we want to divide by 3 feet. Three feet. This is 1. It's 1 jar. That you don't have to do this one each time, but here I want to show is when we multiply by the conversion factor, what we are doing is we are multiplying by 1. This is why we are not changing the number. Yes, we are not changing this quantity because we are multiplying by 1 when we multiply by the conversion factor. Then we have 36 feet and we want to convert into jar. And we need to select the right conversion factor. Yes. We need we need feet in the denominator to cancel out the feet because we don't want feet, we want in jar. And the right conversion factor is this one. Yes. Then here we have 3 feet. One jar. And you can see here is this equals to 1. Yes? When we are multiplying, we are not changing anything because this conversion factor equals to 1. And now feet cancel out and we have in jars. This is the unit we want. Then we have here 36 jar divided by 3. No units here, there's no units if it cancel out. And 36 divided by 3 is 12 jars. And we have 36 feet equal to 12. Now we want to change 18 jars to feet. Yes, 18 jars to feet. And let's start with 18 jars. And we need here jar and we need feet here because we need to cancel out the jar. Then the right conversion factor we need to apply in this case is 1 jar and equals to 3 feet. Yes, this is the right. Why? Because we can cancel out the jar and we had feet, which is the unit we want. Yeah, we want feet. Then we had 18 times 3 feet, and we need is divide by 1, but we don't need to divide by 1. Then 8 times 3 is 24. 3 times 1 is 5, plus 2 is 54 feet. And finally we have 18 jars equal to 54 feet. Now, in some cases, we don't have the direct conversion factor. Then we need to apply the change of conversion factor. And in this case, we use more than one conversion factor to get the answer. And when we don't have the direct conversion factors, we need to use sometimes 2 or sometimes 3 conversion factors to get the answer. Then we need to change, we need to change each jar to inches. Then we don't have jars to inches here, yes, we have jars to feet. That what we can do, but we know 1 foot equals to 12 inches. And what we can do is we can convert first jars into feet using this conversion factor, and then we can convert the feet into inches using the second conversion factor. We will use these 2 conversion factors. How we will write the conversion factors depend on how we need to cancel out the units, what unit we need to cancel out. And let's start, we will write here A jars. Then we don't have the direct conversion factors, but we will convert first the jar into feet. Then we need to write jar in the denominator because we want to cancel out the jar. Yes. Then we had 1 jar, yes, 1 jar, 1 jar, and we had 3 feet. Yes, this is the right way we need to write. And we know it's right because jar cancel out. And we had feet, but we don't want in feet, we want in inches. Then we need to use the second conversion factor. We need to multiply by the second conversion factor. Because we want in inches, we want feet in the denominator. Then we need to use the second conversion factor. 1 feet equals 12 inches. And 1 foot equals 12 inches. And you can see here the feet cancel out. And finally, we had in the inches. This is the unit we want. And let's now try to solve this one. Then 8 times 3 times 12. Divide by 1, then we don't need to write that. And the unit, inches. Then 8 times 3 is equals to 24. 24 times 12 equals to 288. Here we have 288 inches. Then finally we can say 8 yards equals to 288 inches. And in this case, we use two conversion factors because we don't have the direct conversion factor from yard to inches. And you don't have to memorize this conversion, this units of length. You don't have to memorize this one because in the test you will have that, but you need to know how to apply these conversion factors. In this case, we want to convert 5 miles to yard. Then let's see, we don't have direct conversion factor from miles to yard. But we know 1 mile equals to 5,280 feet, yes. And we know 3 feet equals to 1 yard. Then we can use these two conversion factors to get the answer. Then we can convert first miles into feet, and then we can convert the feet into yard using the second conversion factor. Let's do that. Then we had 5 miles. And now we need to convert miles into feet. And we need to write the miles in the denominator because it's the only way we can cancel out the miles. This is the unit we don't want. And we want, for now, feet. And these units cancel out and we have feet. But we don't want, we want the final answer in yard. Then we need to use the other conversion factors. We need feet in the denominator because we need to cancel out. Then we need 3 feet. Yes, we use the other conversion factors and 1 yard on top. Then we had 3 feet, 1 yard. Yes, this is I wrote there. Then now the feet cancel out. And finally we had in yard. This is the unit we want. Then let's see what we had on top. 5 times 5 to 80. And we have yard here. This is multiplication. And we need to divide by 3. Yes, 1 times 3 is 3. Then let's try to multiply this one. We had 5 times 5,280 will be 26,400 yard. To divide by 3 will be 80,800 yard. Then now we can write the answer. Yes, is 5 miles equals to 8,800 yard. And this one is the answer. In this case, we are going to study the units of weight. And in this case, we had two conversion factors. We had 1 pound equals to 16 ounces and 1 ton equals to 2,000 pounds. And we will use these conversion factors to solve this problem. We want to change 6 1/4 pounds to ounce. Then to change this one, and what we had to do is we want to change 6 1/4 pounds to ounce. Now this is we want to convert. This is 1/4. And here we had one direct conversion factor. We know 1 pound equal to 16 ounces. Then we know 1 pound we know 1 pound. Ounce. And we can convert, we can use, let me write this one there. Use 1 pound 16 ounces. Then now we need to use this conversion factor, but the first thing maybe we want to do is we want to convert this mixed number into the fraction number. Then 6 times 3 is 24 plus 1 is 25. 4 pounds. And now we need to decide how we will write the conversion factor. Then we need to cancel out the pounds, and we want to give the answer in ounce. Then we need to cancel out the pounds, and we need to write pounds in the denominator and the ounce on top. And in this way, this cancel out, and the final answer is in ounce, is the units we want. And what we need to do is we need to multiply 25 times 16 divided by 4, and the answer is in ounce. And let's write here. And we can simplify. We divide by 4. Yes, we have 4 here. 16 divided by 4 is 4. Then now 25 times 4 equals to 100. 100 ounce. Then now we can write the answer is 614 pound equals 200 ounce. Let's now solve the next problem. In this case, we want to change 3.2 tons to ounce. Yes, we want to change 3.2 tons to ounce. And let's say we had direct conversion factor. We don't have direct conversion factor, but what we can do is we can convert first tons into pounds, and then we can convert the pounds into ounce. Yes, this is we can do. And in this case, we had to use change of conversion factors. And let me write the conversion factors here. Let's write here 1 pound equal to 16 ounce, and we had 1 equal to 2000 pounds. This is the conversion factors. And let's write here 3.2 tons. Then we will use first this conversion factor. Yes. Ton into, we need to convert into pounds. And the right way we need to write this conversion factor is in the way the tons cancel out. Then 1 ton must be in the denominator and 2000 pounds on top. In this way, these units cancel out, and we have in pounds. But we don't want the answer in pounds. We want the answer in ounce. Then we will use the next conversion factor. And the right way we need to write the conversion factor in the way the pounds cancel out. And 1 pound in the denominator and 16 ounce on top. And in this way, this cancel out, and the final answer is in ounce, and which is the unit we want. And let's see, we had on top 3.2 times 2000 times 16, and in the denominator we had 1 times 1, which is 1. Then we don't need to write that. Then let's now multiply these two numbers. We multiply these two numbers will be 102,400. multiply these two numbers, and will be 102,400 ounces. And now we can write the final answer. This is 3.2 tons equal to 102,400 ounces. Let's write this one. This is also, let's make this one clear. This is the final answer. The next unit we want to discuss is the units of volume. And in American system, we had different units. We had 1 cup equal to 8 fluid ounce. Yes. We had 1 pint equals to 2 cups. 1 quart equal to 2 pints. 1 gallon equal to 2 quarts. Then let's try to use these conversion factors to change, for example, 4.5 pint to fluid ounce, as this is we want to convert. Then what conversion factors we need to use is, let's see, we had some direct conversion factors. We need pint into fluid ounce. Then we don't have direct conversion factor, but what we can do is we can convert this pint into cups, and then we convert the cups into fluid ounce, as this is. And let's write the conversion factors we are going to apply in this case. And we need first to convert the pint into cups, yes, and 1 pint equals to 2 cups is here, yes. And the next thing we want is 1 cup equal to fluid ounce, yes. And to convert this one, then we need to apply the change of conversion. We need to use these two conversion factors. Then we will change first pint into cups, and then cups into fluid ounce. Then let's 4.5 and let's write the first conversion factor, and we need to write this one in the way the pint cancel out. Then we need 1. Let me write this one better. 1 and then we need 2 cups here. And pint cancel out, but we want in fluid ounce. Then we need to use the next conversion factor, and we need to write the conversion factor in the way the cup cancel out. And we need 1 cup here. We had 8 fluid ounce. Cup cancel out, and we had the final unit in fluid ounce is the unit we want. And let's see what we had on top. We had 4.5 times 2 times 8 ounce. We had 1 times 1 when we don't need to write in the denominator. We had just 1. Then if we multiply these numbers together, we had 72 fluid ounce. And now we can write the answer is 4.5 pine equal to 72 fluid ounce. And this is the final answer. Let's see the next problem. We want to change in this case gallons to pint. Yes, this is we want to change that. Let's see what we had here. Gallon to pints. Then we don't have direct conversion factor, but what we can do is we can convert first gallon into quart, and then we can convert the quart into pint, 2 pints. Yes. Then we will use the last two conversion factors. Let's write here the conversion factors we are going to use in this case. Then we will use 1 equals to 2, and the other one is 1 quart. And let's apply these two conversion factors, yes, to change 3.2, let me write this one, 3.2 gallons, 3.2 gallons. Then we start with this. Then first we will convert gallons into quart. Yes. Then we need to write in the way the conversion factor, in the way the gallons cancel out. Then we will have 1 gallon here, and we had 4 quarts on top. Let's cancel out, but we don't want in quart, we want in pint. Then we need to use the next conversion factor. We need 1 quart here, and the reason is we need to cancel out the quart, and we need 2 pint, and this is the unit we want. There's the quart cancel out, and now this. Then let's now multiply what we had on top is 3.2 times 4. Let me write this parenthesis, times 4 times 2 pint. We had 1 times 1 is 1. We don't need to write that. And if we multiply these numbers together, we will have 25.6 pint. 25.6 pint. And finally, we can say 3.2 gallons equal to 0.6 pint. And this is the answer. Let's move to the next. Then the next thing we want to discuss is the units of time. And the units of time we had is 1 minute equals to 60 seconds, 1 hour equals to 60 minutes, 1 day equals to 24 hours, and 1 year equals to 365 days. Then we want to convert 6 years to days. And in this case, we had direct conversion factors, then just we need to use that. Yes, let's write here the conversion factor. We had 1 year, 365 days. And let's write here we had 6 years. And we need to write the conversion factor in the way years cancel out, because it's the unit we don't want. We want in days. Then 1 year in the denominator and 365 days on top. Then the year cancel out, and we need to multiply. That's why here 6 times 365. Here is multiplication. Let me write better because we can get confused with that. And it's 6 times 365. And we have this. If we multiply these numbers together, we will have 2,190. 2,190 days. And finally, we can write here the answer is 6 years, 2,190. This is the answer. Then the next thing we want to solve is how many seconds in a day. Nice. Then we don't have direct conversion factor from seconds in today, seconds today. Then what we had to do is we had to use several conversion factors. Yes? Then what we know is 1 day equals to 24 hours, but 1 hour is 60 minutes and 1 minute is 60 seconds. Then we had to use 3 conversion factors to get the answer, because this is the conversion factors we know. Then let's write here the conversion factors we need. Here is 1 day equals to 24 hours, but 1 hour equal to 60 minutes and 1 minute equals to 60 seconds. And let's use these 3 conversion factors to get, and we had 1 day, and now we need to write 1 day, convert this one in hours first, 24 hours. The day cancel out, but we don't want hours. We want, now we need to convert into minutes, because this is the conversion factor we had. Yes, and 1 hour, 60 minutes. Hours cancel out because it's the units we don't want, but we want in seconds. Then we need to use the next conversion factor. Is 1 minute, is 1 minute equals to 60 seconds. And we know we need to write minutes in the denominator, because it's the only way we can cancel out these 2 minutes. And finally, we had in seconds is the unit we want. And let's see, we need to multiply 1 times 24 times 60 times 60. We had seconds. We had just 1 in the denominator. 1 times 1 is 1. 1 times 1 is 1. And if we multiply these 3 numbers together, 24, 1 times 24 is 24. 24 times 60 times 3 times 60 times 60, we will get 86,400. 86,400 seconds. And now we can write the answer in 1 day. 1 day. We had 86,400 seconds. And this is the last time of conversion factors the conversion units we will study in this section. Then we want to convert units of speed. And we need to remember the speed is defined as distance over time. And in this case, the speed will have units of distance over units of time. Yes. Then units of distance, which is a length, yes, over units of time. This is why we had here 2 different the list for units of length we know in the American system and the units of time we had for American system. And remember, speed is distance over time. This is why we had units of distance over units of time. Distance is a length. In this case, we want to convert 367 feet per second to miles per hour. Yes, this is we want to do. To do that, we will use these conversion factors we had here. And let's see how we will do that. And we had 367 per second. And let's see what conversion factors we need to use. Then we will do this when we will divide the problem in two parts. First, we will convert the units of distance, and then we will convert the units for time, yes, which is in the denominator. And to convert the units for distance, we want feet into miles, then we need to use this conversion factor. Yes. And let's write here the conversion factors we will use first for the distance. This is the conversion factor. And let's write here. Then, because we want in miles, we need to cancel out the feet. And this is feet is in the denominator, and I need to write the right number here. And we had 5,280 feet at 1 mile. As this is the right conversion factors, we need miles on top and feet in the denominator, because feet must be cancelled out. Then now we had miles. This is the unit we want. As miles, we had miles here. Then now we need to take care for the units of time. Then we had seconds. We had seconds, and we want hours. Then what conversion factors we need to use? Then what we can do is we can convert the seconds into minutes, and then the minutes into hours. And we need to use this conversion factor. Yes, we need to convert first the seconds into minutes. And this is the conversion factor, correlate minutes and seconds. And then we need to convert the minutes into hours. Then minutes into hours, this is the conversion factor we need to use. 1 hour, 60 minutes. We need to write the conversion factor in the way the unit we don't want cancel out. Then we had seconds in the denominator. We need seconds here. In this way, this cancel out. Then we need to write 60 seconds on top and 1 minute in the denominator. Yes, 1 minute here, 60 seconds on top. In this way, seconds cancel out. Yes, and we had minutes, but we need hours. Then we will use the other conversion factor. Then we had minutes here. We need cancel out the minutes. Then we need 60 minutes on top, 1 hour. We had 60 minutes on top. Let me 60 minutes on top here, and 1 hour in the denominator. Because in this way, this minute cancel out with this minutes. And finally, we had hour. And hour must be in the denominator. Yes, we need hours here. Then the answer is in miles per hour. This is miles per hour. This is the units we want. Now let's multiply the numbers. What numbers we had on top? We had 367 times 60. Yes, times 60 divide by, then we had 367 times 60 divide by 5,280 280 times 1, then just we need to divide by. What units we had on top? Miles. What units we had on bottom? Hours. Yes. And now just we need to multiply these numbers together, and on top we had, let's see, we had 1,321,200 miles. Divide by hours. If we divide these two numbers together, we had 252 miles per hour. And now we can write the answer is 300. Let me write here 367 feet per second equals to 250.2 miles per hour. And this is high speed, yes, because the speed in the highway is about 60 miles per hour. This one is 250. This is the answer. And now let's go with the last problem we will discuss in this section. Then we want to solve this problem. This is a word problem. When a woman's softball pitcher can throw her ball at 60 miles per hour. How fast is this in feet per second? And we had 60 miles per hour, but we want to convert this one. This is hour. We want to convert this one in feet per second. 60 miles per hour. We want to convert this one into feet per second. And let's see what we had to do. Yes, then remember, if you had speed units, we want to convert first the distance units, and then we want to convert the time units. And to convert miles into feet, we will use this conversion factor. Yes, and let's do it. 60 miles per hour, and let's start with the distance units, and we need to write this one in the way the miles cancel out. Then will be 1 mile to feet, and the miles cancel out, and we had in feet. Yes, the answer, and this is we want feet. Yes, we had feet. Now we need to convert hours into seconds. Then what we can do is we can convert hours into minutes first, and then we can convert the minutes into seconds. Just we need to be careful to write the conversion factor in the right way. Yes, then because we need to cancel out the hours, we need hours on top. And let me write here hours like that. And 1 hour equals to 60 minutes. And in this way, hours cancel out. But we don't want the answer in minutes. We want the answer in seconds. Then we need to apply the other conversion factor. We want 1 minute. Yes. To 60 seconds. And the minutes cancel out. And finally, we had in seconds is the units we want. We had feet per seconds. And let's now multiply the numbers together. We had 60 times 5,000, 280, and we had feet on top. Here we had 60 times 60. It's 60 times 60, and we had seconds in the denominator. And because we had multiplication, we can cancel out these two numbers, and we can divide 5,280 divided by 16, which is 88 feet over seconds. Then now we can write 60 miles per hour equal to feet per second. And this is the final answer. The 60 miles per hour equals to 88 feet per second. And this is all I had for today. Bye-bye.